Many of you wonder what are AI agents or how to work with that, what they look like, which theory is behind this. So today I'm going to try to explain the theory and the concepts or key concepts behind what defines AI agents. So I want to begin with a very good definition of Hugging Face, which is around the AI agent, so to say, paradigm or logic. And it consists of programs where LLM outputs control the workflow, which means that you can imagine that the LLM output is about to make decision about the next step. So, and then AI agent or agentic AI systems are simply AI solutions where you can have one of these, at least one of these 4 points. For example, you have either a multiple LLM calls, or you can have LLMs with the ability to use tools. Like, for example, suppose we have an LLM which uses pandas to make calculations and mathematical operations in an Excel data sheet. You have also an environment where the LLMs interact and a planner to coordinate the activities. The planner is very important in such AI design systems. So, in order to understand, we need to distinguish between two design patterns. One is simple workflows where you can have a combination of orchestrated tools, or let's say, for instance, code snippets or code paths and LLM outputs, or we have the agents, which are the systems where LLMs dynamically direct their processes and tool usage. And these are the two distinguished systems according to Anthropic, and this is of course the most used AI agent system patterns. For this, we distinguish five workflow types. The last one is the most important one that we're about to see later on. So we will begin with a prompt chaining, which is a very simple task. You can imagine having a problem. You want to go high level, break it down into the finest details. For example, you want to ask the LLM to propose an investment idea. Then you want to go down into some niche decision about that investment idea. For instance, you want to invest your money in ATF, then the next LLM you will have, for instance, which is an optional here, as you see in the graph, you have a gate, which is, let's say, a classifier of the ATF wallets or whatever, and or according to your budget it can direct you. Then this next LLM is about to choose the your preferences, and the third one could be to decide whether you can invest in that wallet or ETF portfolio or whatever or not. So this is, of course, a simple workflow. You can have more than just one LLM. And this prompt chaining is, of course, very simple in its architecture. Then we have the routing. And the routing is something which is very important whenever you are dealing with systems, especially chatbots. And this applies to chatbots. Why? Because in a chatbot, you want to have a very specific task. Let's say you want to have a chatbot which is able to direct you to have some very specific tasks. For instance, you want to analyze some data sheet, and this data sheet, you can either ask questions about it. Let's say you have a retrieval augmented generation. You want also to make some data analytics. For instance, you want to plot some, I don't know, some data, some columns, whatever, and you want to do mathematical operations. So in this case, the LLM, which is a router, here it classifies the user query and directs it to the specific agent, and of course the agent will output the, after making the necessary operation, either it's a RAG um, or let's say plot or whatever, it will give you the right output. Now we have the parallelization, and this is something where you can imagine having a big task. Let's say, for example, you have a very big document um, where you want to summarize or verify or make some assessment or whatever. So this coordinator here is a kind of script or code or software. It could be something like that. And it automatically splits the document into parts. Then it assigns to each LLM um, what part is about to do what. And here in this case, you can, of course, direct it either to, this should be LLM 1, 2, 3, of course. And for instance, LLM 1 would take the pages from 30 to from 1 to 30, then 2 would be taking the pages from 31 to 60, and the third would take the rest. And this then, the aggregator is then about to combine these results again and give the output. Now we do have, in contrary to this, now we have the orchestrator, and this orchestrator is, of course, the AI agent, which, in contrast to the coordinator, which is a fixed code, will take the decision on its own. Maybe it could estimate that the first LLM would take the first part, which is not necessarily 30%, but rather 20%. Then the second one would take, for some reason, 40%, and then we have 50% for the third. And then the synthesizers, which is, of course, another LLM, would be able to synthesize the rest. You can imagine also them taking the same LLM actually and repeating the same task and then making the average. This is also possible. It depends on the use case which you are dealing with, and then this is the very most important design, so to say, or workflow. You have an LLM generator, it outputs some solution, and you have an evaluator which gives feedback, either accepts the output and then gives the output, or it will give a feedback and give the of course, it won't output it. First of all, it will feedback the solution with some comments, with maybe some critics, and then the LLM generator has to, of course, react again and give another solution, which should be then accepted. This is very important because you need to make sure that whenever you're dealing with robustness, reliance, or reliable AI systems, you need to make sure that this is, of course, working. The LLM evaluator would be an expert in some field, or It is based on, let's say, for instance, retrieval augmented generation system or anything like this. This is, of course, a um, very common architecture or workflow in AI agent systems. So this is it. For this small introduction, or let's say explanation on agentic workflow design patterns. If you do have any question, don't hesitate. Just write it in the comment section below. And of course, feel free to subscribe to the channel. We'll be glad to seeing you react and not missing any of the next videos. Thank you for watching, and until the next time.